Hi guys, my name is Vlada, and the previous video we did the parameterization of this curve. Curve L is this green curve from this point to this point, and this is its parameterization, and this was the integral we are solving. So let's do the second step. Second step will be to calculate the line element ds, which is given by formula square root of derivative of x squared plus derivative of y squared times dt. Okay. Let's calculate derivatives. Derivative of x is equal to derivative of 1 plus cosine t, which is equal to 0 plus sin t. Minus sin. Okay, and derivative of y is equal to derivative of sin t, and that is equal to cosine t. So let's change that here. We have square root of minus sin t squared. Okay, I will do just this. Okay, this frame should be red. Okay, nice. And plus derivative of y is cosine t squared times dt, and this is equal to sin t squared plus sin t squared plus cosine t squared times dt, and from the trigonometric identity, sin squared plus cosine squared is equal to 1, so we have square root of 1, that is equal to 1 times dt, which is equal to dt. So we got our ds and it's equal to dt. Let's frame this second step, and let's do the third step. Third step is to plug in everything. Okay, integral over the curve of this function square root of x squared plus y squared times ds is equal to ordinary integral with boundaries 3 pi over 2 and 5 pi over 2, or 5 pi halves. Okay, and we have square root of x is equal to 1 plus cosine t, 1 plus cosine t squared plus, and y is equal to sin t. So we have sin t squared times ds, and ds is equal to dt. Okay, let's do this ordinary integral. First, let's rearrange this expression in the square root. We have 1 plus 2 cosine t plus cosine t squared plus sin t squared times dt, and this is equal to 1. So we have ordinary integral of the function square root of 1 plus 1, 2 plus 2 times cosine t times dt. Okay. We need a trigonometric identity to rearrange this, and it is known that cosine t half squared is equal to 1 plus cosine t halves. Okay, and we will multiply this equality with 4. So we get 4 times cosine t half squared is equal to 2 plus 2 cosine t. Okay, this is the identity that I needed. 2 plus 2 times cosine t is equal to 4 times cosine t half squared. Okay, so we have integral from 3 pi over 2 to 5 pi over 2, 5 pi halves, whatever. And here we have 4 times cosine t half squared okay, squared times dt. Oh, I don't have room for dt. I will just expand my canvas a little bit. 10,300. That's enough. dt for 1 dt. Okay, times dt. So we only need to solve this integral, and our job is done here. Okay, I will calculate this integral somewhere over here where I have room to do that. Integral from 3 pi over 2 to 5 pi over 2 of square root of 4 times cosine t half squared dt. First, this number 4 becomes 2 when it comes out of this square root. And we have square root of cosine t half squared times dt. So let's remind ourselves with one identity. Square root of x squared is equal to absolute value of x. So this is equal to absolute value of cosine t half. Right bracket, and let's close this absolute value times dt. Okay, so let's do the substitution. For example, t half is equal to some u. So dt half is equal to du, which means that dt is equal to 2 times du. This will be our substitution, and let's change boundaries. Don't forget to do that. T and u. Okay, t is equal to 3 pi halves and 5 pi halves. If t is equal to this, u will be 3 pi quarters and 5 pi quarters. So we have 2 times integral from 3 okay, it's okay, 3 pi quarters to 5 pi quarters of absolute cosine u times 2 du's. Okay, this constant will go out, so we have something like this. 4 integrals from 3 pi halves to 5 pi halves of absolute, it's hard for me to say absolute value, maybe because my language, my native language don't have such pronunciation of that word. On Serbian we call it apsolutna, and it's difficult a little bit for me to say absolute, so sorry for that, but you understand what does that mean. Okay, oh sorry, quarters, my mistake. Nice. Okay, let's just see the sign of cosine function, because this absolute value is equal to x is if x is greater or equal to 0, and minus x if x is less than 0. So we need a sign of cosine t in order to determine the sign of this of cosine t. So let's use something that is called Desmos. Oh, sorry. Desmos calculator. And let's look at the function cosine from 3 pi quarters to 5 pi quarters. So this blue line is 3 pi quarters and this green line is 5 pi quarters. So we see that cosine is negative here. Okay, we also see that we have some values here, but we will see what we are going with that values. Actually, we don't need that values. We need the values of sin 3 pi quarters and sin 5 pi quarters when we do this integral, when we solve this integral. But we have minus here because cosine is negative from 3 pi quarters to 5 pi quarters. Okay, so we have minus cosine u times du. Okay, I will write that minus here, and using Newton-Leibniz formula, we have minus 4 times sin u, integral of primitive function of cosine is sin, from 3 pi quarters to 5 pi quarters, which is equal to minus 4 times sin 5 pi quarters minus sin 3 pi quarters. Okay, this number here remind yourselves is equal to minus, oh sorry, where is that, sin is equal to no, we are looking at this number, sin of 5 pi quarters is equal to minus square root of 2 over 2, and this number here is equal to, sorry, come on, go, sin of 3 pi quarters is equal to square root of 2 over 2. Okay, so we have that this expression in the brackets is equal to minus square root of 2, so our final solution is 4 times square root of 2. Okay, and our job here is done. That was nice example, and see ya in next video. Bye bye.